Welcome to the deep dive. We've got a fascinating set of sources you sent over about the winter 2025-2026 outlook, and it's shaping up to be pretty unusual.
Yeah, definitely complex.
Right, it looks like a potential cold surprise, but it's built on, well, competing factors. So our mission today is really to dig into that paradox. Why the competition between the atmosphere and ocean, and why might this winter be so volatile beyond just looking at seasonal averages?
Okay, so the starting point has to be the Pacific. That's usually our baseline. We're looking at a weak La Nina event.
Weak La Nina, okay.
Yeah, and it looks set to stick around through, say, December, January, February 2026. The projections put the key Niño 3.4 index somewhere between minus 0.5 and minus 0.9 degrees Celsius, so not a strong one.
And normally La Nina means, cooler and wetter up north, warmer, drier south for the U.S. But if it's weak, how much stock can we put in that typical pattern?
That's exactly the issue. Because it's weak, the atmospheric signal it generates is, well, it's noisy. It doesn't shout loud enough, you could say. So it could easily get drowned out or overridden by other things happening in the atmosphere. We can't just rely on that classic La Nina playbook this time. We've got to look elsewhere for the stronger signals, especially for the cold.
All right, so if the Pacific isn't the main driver for strong impacts, where is the disruption coming from? What should we be watching?
Well, this is where it gets really interesting. We have to look up, way up into the stratosphere, about 20 miles high.
To stratosphere, okay.
What stands out this year is a strong, persistent easterly phase of the quasi-biennial oscillation, or QBO. It's often called the negative QBO.
Right, the QBO, that equatorial wind pattern.
Yeah, exactly. And when it's strongly easterly like this, there's a pretty robust dynamic link to a weaker, more unstable stratospheric polar vortex, the PV, for the whole winter.
Ah, so the QBO is kind of preconditioning the polar vortex to be less stable.
Precisely. And an unstable vortex is, where the potential for serious cold outbreaks comes from.
How high is that potential? How likely are we to see that instability translate into, Arctic air spilling south?
Well, this unstable setup significantly boosts the odds of a major sudden stratospheric warming event, an SSW.
The SSW, that's the big one.
That's the big one. It's where the stratosphere suddenly heats up, blows up the vortex structure, basically. The sources we looked at put the probability somewhere between 60, maybe even 75%.
Wow, that's high.
It is. Peak potential looks like January through March. And that SSW is really the main way you get that huge reservoir of Arctic cold dislodged and pushed down into the mid-latitudes.
Okay, so that covers the sort of mid to late winter major cold risk tied to the SSW. But the sources also flag something else, an early winter cold surprise, specifically for early December. That sounds like a separate event.
It is, yes. It looks like a distinct pattern showing up in the extended range models. The key mechanism there seems to be the development of a really strong blocking high-pressure system over Greenland.
A Greenland block, okay.
Yeah, a classic high-latitude block. It essentially sets up a direct pipeline, a sort of cold corridor for Arctic air to plunge right into the central and eastern U.S.
And what gives us confidence in that specific early December forecast?
Well, complementing that Greenland block pattern is a forecast for a negative phase of the North Atlantic Oscillation, the NAO, particularly in December and January.
Right, the negative NAO often goes hand in hand with Greenland blocking, so they reinforce each other.
They do. It creates this constructive interference, pushing strongly towards that early cold shock.
Yeah.
So we have pretty high confidence in that specific earlier event.
Okay, so we have this early cold shot potential from blocking, and then the later, perhaps more severe cold potential linked to the unstable vortex and SSW risk. Lots of volatility. What does this actually mean for you, depending on where you live? Which areas are looking at the biggest swings?
There seem to be two main battleground zones, if you will. First, the Northeast and the Mid-Atlantic. For them, there's a high potential for a really volatile winter. Maybe what some might call an old-school winter. You've got the weak La Nina influence, the negative NAO favoring blocking, plus the elevated SSW risk later on. That's a potent mix for significant cold outbreaks and potentially nor'easters.
Right, that coastal storm threat increases with that kind of pattern. And the other key zone?
That'd be the Great Plains and the Midwest.
Yeah.
They are really in the direct line of fire if, and still an if, but if that major polar vortex disruption, the SSW, actually happens. If the vortex splits or gets displaced significantly, that region is highly susceptible to the most prolonged, most severe cold snaps. The Arctic air just spills right down.
Okay, let's try to wrap this up for everyone listening. The main takeaway, it seems, isn't necessarily that the entire winter will average out colder than normal everywhere.
No, probably not overall averages.
Right. The real story is the high potential for shorter periods of high-impact, severe cold, both early on, maybe December, and then again later, perhaps into March. So being prepared for volatility for those sharp swings seems to be the crucial message.
Absolutely. Preparedness for those intense, if perhaps shorter-lived, cold events is key. But, there's always a flip side to consider, a potential forecast bust.
Okay. What's the main way this forecast could go wrong?
Well, here's something for you to think about. What if the polar vortex just doesn't break down? Despite the unfavorable QBO background state pointing towards weakness, what if it manages to stay strong and stable all winter?
A stable vortex scenario.
Exactly. That would be the primary way this forecast busts. If the vortex holds together, keeps the coldest air locked up near the pole, and most mid-latitude areas, including those we talked about, would end up having a much, much milder winter than this outlook suggests. It essentially negates the cold surprise.
Interesting. So the state of the polar vortex is really the linchpin here. Whether it's the early blocking or the later SSW risk, those stratospheric signals are telling us to brace for potential intensity. But there's always that chance the vortex holds firm. Definitely something to keep an eye on as we head towards the end of the year.